Hello, I'm Hyuntak Kim from CJ Corporation. Today, in this paper, we explore how large language models can be orchestrated to summarize 100K token narratives, such as books, scripts, and TV shows, maintaining the structure and coherence. First, let's start with talking about why is narrative summarization uniquely challenging. Unlike general summarization tasks, narrative summarization requires literally understanding the characters or plot arcs to understand its thematic context. And also, it requires long-range dependencies, often spanning over 100K tokens, and understanding how to appropriately connect descriptions with dialogues. So let's see the literature complexity through an example, the Parasite movie. To summarize Parasite well, you should understand the characteristics of the Kitek and Park family. One is poor and one is rich. In the narrative, they interact together within the events. And finally, the characters and events deliver an important thematic message, the polarization. So, summarizing narratives means more than just extracting plot points. It requires capturing character dynamics or thematic arcs. And the wrong text feature is also challenging for narrative summarization. For instance, the Brothers Karamazov's whole token length is 160K, but the human-written golden summary is only 1K in length. So, the narrative summarization often requires an extreme text compression rate, while maintaining its original narrative flow and its content. One more unique feature is that narratives blend dialogue and prose. Large language models often struggle with this hybrid format, especially when inferencing the context from character interactions. And in this slide, let's talk about the previous work's problems. While prior work shows promising results for use, short-form text, or generic long-form summarization, most approaches struggle to scale to narrative domains. This because they lack length control and overlook the structure demands of a narrative format. Our key insight, rather than pushing a single LLM harder, we decompose the problems into modular agent roles. Therefore, we set three research questions. Question 1. How can we process long context coherently for long-form summarization? And question 2. How can we create a narrative domain adapted summarizer? And the last question 3. How can we precisely summarize to the target length? So, as the answer of these research questions, we propose NexusSum, a novel multi-LLM agent summarizer. NexusSum takes narratives which has hybrid format and long-form features as the input text, and then generates summaries using multi-LLM framework, which considering coherency, narrative specialty, and precise length targeting, without any model training. Let's discuss in more detail how the NexusSum framework gives solution to the research questions. We structured the summarization process into three LLM agents: preprocessor, summarizer, and compressor. Each are optimized for a specific role in handling long narratives. So before talking about agents, let's do a quick check about the chunk and concat method. This enables coherent long context processing through hierarchical merging across all agent stages. Each chunk's text inputs into small sizes, and then processes chunks through independent LLM requests, and then hierarchically merges the results. This approach allows NexusSum to process infinite input text size without omitting any information, and this addresses research question 1. Now, let's talk about each agent. Our framework has three LLM agents that process narratives into summaries. First, the preprocessor rewrites dialogues into coherent third-person prose, and this lowers the complexity of processing the narrative content in downstream stages. And the second agent, Summarizer, extracts characters, events, and their interactions. It is instructed with prompt to focus on the narrative's key elements while generating summaries. These first two agents are designed as narrative domain adapted agents, which directly address research question 2, the narrative domain adaptation challenge. And finally, the compressor enforces length control via iterative compression until the output meets the target length. This agent enables us to steer the output toward the target length without truncating or overgenerating. Therefore, the compressor addresses research question 3, the accurate output length generation challenge. Now, we've covered our methodology. Let's move on to evaluation. To evaluate NexusSum's performance, we consolidated long-form narrative benchmarks and compared results with previous works. First dataset is BookSum, a novel-based summarization dataset, which has longest input-output text size. Next, Mensa and MovieSum contain movie script summaries, which focus on cinematic content. Some screen FD derives from TV shows and episodes featuring dynamic speaker tones and minimal context. These datasets span 100K token novels, 40K token movie scripts, and 10K length fast-paced TV dialogue, which capture a broad spectrum of narrative formats. These four benchmarks evaluate NexusSum's comprehensive coverage across different narrative formats, from novels to movies and to TV shows. Now, in this slide, we show how NexusSum performed across these diverse narrative domains. In the results, our framework shows state-of-the-art performance for the benchmarks in BERT score. Specifically, on BookSum, NexusSum boosts BERT score by over 30% and shows 7.1% improvements for MovieSum versus prior SOTA methods, which demonstrates its ability to scale to long-form narrative input. And we also conducted ablation study. This demonstrates that each agent contributes to overall improvements. Especially the summarizer and compressor provide the largest improvements, which highlights the value of NexusSum's iterative summarization system. We also examine NexusSum's precise length control ability. It achieves superior output length control with high length adherence rate across all target lengths. The LAR measures how well a summary matches the target word count, and NexusSum demonstrates excellent performance across different target lengths. We also calculate the inference time complexity. Unlike zero-shot summarization, which scales quadratically, ours, NexusSum, its pipeline runs in ON time, making it practical for real-world long inputs. And we also conducted human evaluation with 3 K-drama experts across 3 drama genres. We evaluated the summaries using 4 dimensions: key events, flow, factuality, and readability, which are scored on a 1 to 5 scale. So human judges consistently preferred NexusSum over zero-shot LLM in terms of coherence and factual consistency. However, the higher readability score in LLM zero-shot summaries gives the NexusSum the room for improvement in readability. And this motivated a post-processing step to refine the NexusSum summary by transferring the text style to match the zero-shot summary, which reduces readability gaps while maintaining coherence and factuality. So in conclusion, we presented a NexusSum, a novel multi-agent LLM framework, which provides a scalable and controllable approach to long-form narrative summarization, and this achieves state-of-the-art results without any fine-tuning. And based on the strong empirical gains in this research, we demonstrate that this multi-agent framework could support domains like clinical reports, legal documents, or scientific writing, where structured, controllable summarization is vital. Therefore, our study provides groundwork for further research in both narrative summarization and also for the multi-LLM frameworks. So thank you for your attention, and for more information about our research, contact us via email. Thank you.